Hello everyone. Welcome to the talk on self-service metadata-driven data loader platform from Walmart Global Tech. Myself, Subramanya, and my colleague Mani will be talking about it for the next 30 minutes. Just a brief introduction about us. Myself, Subramanya Mulgund, working as a senior software engineer in the feature engineering group for personalization at Walmart Global Tech. Mani.
Yeah, my name is Manimuthu Aayyannan. I'm a senior engineering manager at Walmart Global Tech, currently leading some of the key initiative under personalization. Over to you.
Let's take a look at the agenda for today's talk. What is personalization at Walmart? What are some of the challenges that we face in today's world when we try to load the data to a persistent data store? What are the solution approaches? What is the system architecture at a high level? And under the hood, how does the system perform with the various connectors, metadata, orchestrator, and a schedule optimizer, an intelligent module, and a telemetry, which provides the dashboard for the users. What is personalization at Walmart? So for any customer, if we are able to provide a personalized experience, that is a big gain. For us to do that, we need to understand the customer well. And for us to understand the customer well, we need to understand the patterns about how the customer shops, how the customer interacts with Walmart website, how the customer goes to the store and does the purchase or does a pickup of any item. So we have almost like 220 million customers and different guests who are visiting almost 10,500 stores across multiple countries. Walmart operates with different banners. So we have a lot of e-commerce websites and a lot of stores. Even in the US, we have like 4,600 stores approximately. You can just imagine the amount of data that we have to deal with. With such a high volume of customers and so many stores, billions of product impressions are served online, and that generates huge amount of data in terms of petabytes. Here at feature engineering team, we run thousands of data applications to generate features that power the personalized recommendations to our customers. As you can see through the building blocks, if we are able to understand customers interaction with all the purchases that he does on the general merchandise, we are able to understand the customer a little bit. And with all the pickups, all the store visits that the customer does, we are able to understand the customer even better. And with the whole picture personalization, we are able to understand the customer a lot more by taking all of these factors into account. What is personalization at a high level? What are various life cycles that we follow and how are the teams organized within personalization? Here we have the application lifecycle management, which is carried out by various engineers, categorically primarized as data engineers, data scientists, web service layer folks, the data analysts, who work on various modules uh, in order to ensure the security of the data, the logging of all the systems is appropriate, the features are powered, there is alerting and monitoring, and there are dashboards to keep track of all the statistics. So some of the modules would be like user experience to power the customer with an enriched UI, the access control with security in place, the data apps, which have a lot of data to be loaded onto the persistent store, and the processing of the data itself, which would be through streaming, the real-time, in-memory data processing using a lot of NoSQL persistent data stores to store the final data, and a lot of analytical processing that happens on top of that as well. We are a multi-data center and a public cloud. Okay, what are some of the challenges that we have in our current solution that we are going to propose with? What are some of the challenges that we have been facing so far? So the data application onboarding requires a lot of manual hand coding, and developers need time to develop, integrate, test, and solve the underlying complexities. What does that mean? So basically, if any application needs to load the data into the persistent store, they have to go through a various phases, which include a lot of redundant steps to develop, to code a lot of data, and then to also make sure that the system is secure because it deals with a lot of customer data. We do not want the customer data to be insecure. And that also brings in building functionality rich application, which needs integration with various big data technologies. and a wide array of data sources, which include a lot of sinks and data processors. And what that means? It means that there is an isolated deployment across various machines, VMs, etc., where each of the application teams are trying to deploy, and there is no one single source to control the resource allocation or one single source to change the scheduling for any of these applications, which also introduces a high level of latency to our serving layer, which could impact the customers on their personalized experience. As take for an example, like there are two applications which are trying to load the data at same time, and one of it is a low priority one, which is a larger volume, but the other one could be a high priority one with a smaller volume. We definitely want the higher volume but a lower priority one to be deprioritized and make sure that the high priority one goes into the persistent data store first. So that is not being able to achieve in the current system. So what are some of the challenges if we take a look at it pictorially? As you can see, like each of the application owners, whenever they try to load their data, they have to go through these various steps, which are redundant across application 1 to n. And for all of the modules, be it like specifying the source system, target system, come up with their own processors, parsers, and the different schedule that they have to maintain. And of course, like they have to also maintain like different telemetry dashboards to see the statistics and take care of the resource utilization on their own, which could cause a resource crunch across the whole cluster. This looks very cumbersome and fragile. Let's take a look at our solution, which simplifies this whole process. The data loader platform takes care of multiple things. As you can see, like the application 1 to n just need to configure what they are supposed to load. By that, what we mean, they just need to specify what is the source system, like where is their source data residing, and what is the target system, where they want to load the final data into, which is the persistent data store. And the rest of the components is all taken care by the data loader platform under the hood. As you can see there are a lot of parsers which support different data file formats, a lot of connectors which give the capability to specify different formats like Kafka, Cassandra, or it could be any other application platform that you could think about, right? And the processors take care of doing this in-memory processing and loading the data, the schedulers to deal with different application schedules, the dashboards, like a one-stop solution which show the various statistics for all the applications, the execution plan, which shows the current execution that has been in progress and also the past history applications that have completed the data load. So the user just needs to configure it through an enriched UI and then test and deploy. That is the only step that the user needs to perform. This solution approach brings in the capability of onboarding through plug and play, which can be served as a centralized data platform across the whole organization. It also gives an abstraction layer to build the workflow orchestration that simplifies a lot of things, which includes like several complex service integrations and results in faster time to deployment. An enriched UI also increases the developer's productivity because it provides rich features to specify the connectors and also to specify which data format that the user is trying to load to. And an intelligent system under the hood takes into account all of these parameters, redesigns the priority for each of the applications frequently to make sure that the high priority ones always go to the data persistent store first compared to the low priority ones. And our smart run schedule pool ensures that this happens for all the applications. At a high level, we want to take a look at the system architecture. The top block diagrams show the various modules, and the below one represents each of those modules in detail. How does the process look like end to end? An user logs in through the SSO credentials, and the user looks at the dashboard. If the user wants to onboard a new app, he has a reference apps which he can refer to, how to provide the various parameters. So when the user is ready to onboard the new app, he creates a new application by choosing the connectors and the data file formats where the data has to go to eventually and where the data is currently residing. It could be cross data platform, like one cloud to another cloud altogether. What does it do when the user has specified all of these and clicks on submit? The user would have specified a schedule, and at that exact schedule, the orchestrator kicks in and reprioritizes all the current jobs that have been running by taking into account how priority or how critical is this application that onboarded recently to go to the data store. Should it be at the end of the queue? Should it be at the top of the queue? Where should this fit in? The smart orchestrator optimizer makes sure that this goes into the queue accordingly and splits up into different instances and submits them to the core engine. The core engine takes care of loading this data in different Spark sessions to the data store. And through this diagram, you can see like there is a scheduler component where the user would have specified the schedule at what time the job needs to run. It could be a weekly job, it could be a daily job, it could be an hourly job. So there are various parameters that the user could specify. The resource optimizer makes sure that we repartition the data. If the data is not looking appropriate, there could be data which is of high volume but not distributed uniformly. The repartition is also taken care by the data platform. We accordingly allocate the resources. And in order to make sure, like if it's a dry run, we talk to the stage environment and make sure that the data loads to the stage. If it's the actual production run, we pull the corresponding artifactory from the artifactory, the centralized artifactory URL, and make sure that the data load happens to the prod environment. And finally, all of these steps, once they are complete, the user can take a look at the telemetry dashboard with the current run, how did the data load go, and all the past previous runs. If the user wants to take a note of how the app has been loading, is there a trend in the increase in the data, or what has been the statistics so far? Let's take a look at the detailed application metadata under the hood. I would pass it over to Mani.
Thank you, Subbu. Thanks for giving the quick introduction and walking through some of architecture components. Let's talk about some of the underlying components powering this platform. The first one is metadata. As you see on the screen, these are the metadata schemas powering the platform. App info is one of the key table where we record all the application related attributes and configurations and what kind of application. Is it a batch or near real-time application, or what is the priority of this application? All these attributes are recorded under this application information table. And we have app loader service, which is another important table of this metadata system. So each application can have a number of data loader service. For example, if I have a use case where I need to consume the data from GCS and load it to Cassandra, and I can create one data loader service for this requirement. And under this table where we can record all the configuration about what's my source logic, what's my target, what's my write mode options, and everything can be recorded here. And if I have another module where I want to read the data from Cassandra and run, apply some transformation and send it to Kafka topic, right? So I can create another data loader service for this requirement and build this orchestration for the same application. So this way, like user can build their orchestration flow based on the requirement, and which each module can be represented as the app loader data service. And we have app run status table. This is responsible to store all the run statuses of our application and storing the run metrics of the application run instances. And we have some more tables like which kind of like stores the configuration about the optimized run instances of all these app loader services. So those will be like recorded in an independent tables. We do have a app schedule which will store all the schedule information of your application. This platform is responsible for storing the configuration, executing the application business logic, and also take care of the scheduling. And we do have some more dimension tables like app core group, app loader type, and app user and app domain. These are the dimension table covering the metadata system. And then we have connectors is one another important component of this platform. We have different parsers and connectors integrated within this platform. And we have like for all the standard data formats like JSON, Arrow, Parquet, and CSV, we have already created a parser which user can simply plug and play those configuration in the UI, and which those configuration can be recorded in the metadata store that we discussed about. And these configuration also help us to optimize the resource allocation effectively throughout the platform. And last importantly, we have implemented the custom UDFs on top of these different source and target systems. These UDF, for example, if I have a use case where I need to fetch the key from JSON payload, like I have multiple usage of this particular requirement, then I can create a simple SQL UDF on top of this and expose it in the SQL layer where user like simply can access this UDF in their SQL logic. Let's take an example of how the simple UDF can be created on top of the any API calls. So, for example, if I have to integrate any of the API service within the data pipeline, that requires a lot of effort. So we need to make sure we have authentication and authorization in place, and need to create a secure client to talk to the service and get the required response needed. So it's required a lot of manual coding in terms of integrating these services. So what we have done is we have created a UDF on top of this functionality and exposed this UDF as a SQL UDF in the SQL layer. So in the UI, users simply they have to use that UDF in the SQL queries as you see on the screen. So for example, if I have a API something called to get the account status of a customers, so we created a get account status as a SQL UDF and exposed it in the UI layer, where users simply pass the customer ID to this SQL UDF and get the response that they needed for the requirements. So this is the example of creating the sample domain API call in the SQL UDF. And then we have orchestrator. So orchestrator is one another important component of this platform. So this is responsible for building the optimized execution plan for any applications. Let's say we have high priority applications and low priority applications. So irrespective of priority, so we kind of like based on our threshold value. So orchestrator builds the optimized plan. Like if we have some application with 1 terabyte of data. So if we have the threshold value for each executor can process only 10 GB of data, this optimizer generate the kind of like 10 small instance of those particular applications, so which can be picked by the executor and executed in a parallel manner. And then we have schedule optimizer. So once we have the optimized plan generated by the orchestrator, our schedule optimizer kind of like picks up those execution plans and assigns the small priority for those run instances. So it's purely based on the priority of this application and runtime and criticality of the applications. So with this process, with this schedule optimizer, the top priority jobs takes precedence over the low priority applications. And if though we have like long running low priority application blocking the complete resources at any point in time, this schedule optimizer pass the low priority application and enqueue the top priority application in between to take precedence over low priority applications. And this is the illustration of the schedule optimizer. So you can understand more about the schedule optimizer. For example, if we have a current schedule pool with low priority applications, where we have all non-core applications are running. Let's assuming we have 2 executors running in parallel, and 2 instances are already complete, 2 instances are in progress, and 2 instances from non-core application is in waiting status. At 10:30, let's say we have a high priority applications are coming. There are 4 instances to be executed, and 1 low priority application also coming in the incoming schedule pool. And after that you can see the updated schedule pool, like where high priority 10:30 applications has taken up precedence over low priority application. All the pending instance of current low priority applications are sent back to the backlog, as you see on the screen. So this way, like, we can help achieving the high priority applications in executing in a with high priority window. So we can meet the business SLA for high priority application compared to low priority applications. We can also avoid the latency being introduced to our target systems. And then we have a telemetry component. So this is more of a real-time dashboard that we provide to a customer. So they can see the different insights about the different application they're onboarding, and we kind of like read through the different signals throughout their application execution and provide the real-time analytics on top of those application executions. And user can also set the alert and notifications for their application based on the different scenarios. Can be failure scenario, it can be sudden spike in the data trend, or it can be anything. So we provide wide array of different options for our users. And also user can do a retrospection of their application, how effectively they are using their application. Are there any failure in the recent time? They can easily go and debug their application through this telemetry system. By putting the pieces together, so these are the key attributes powering our platform. So of course, it's a self-service plug and play platform where user go and configure their business logic, and which is being recorded to our metadata store to achieve the low or no code platform, right? So we have different executions engines, like we have Spark and BQ and so on, and it's a purely cloud native platform, and we have version control, so CI/CD automated deployment. So user don't have to worry about taking the backup of every release they are doing. So this platform is capable of taking the backup of any changes that being deployed to production. And we have, like I said, different source and target system integrated, and we continue to integrate new system. And this it's a one-time effort and make it available throughout the platform. And we have with this platform, user can easily manage their application and their life cycle. And also we have telemetry system to provide the insights about the different application they are onboarding through this platform. As an outcome of this initiative, we could see quite turnaround time from of any development, any application onboarding from weeks to days, and developer productivity has been increased by multiple folds. And most importantly, non-engineering team can also leverage this platform to build the complex application with a basic knowledge of SQL. And the intelligent app execution is smart execution optimizer, schedule optimizer can help us to achieve the meeting the high priority application SLAs on time. So with that said, we are concluding our presentation. Any questions? Thank you.
Thank you.